An overhead bin, a quantity of fine sand is poured upon a horizontal surface. The shape is a cone. So let's draw a cone. And so what we're saying is we're trying to pour some sand over here. So this is your horizontal surface. And basically it's going to filter through the sand. So the sand would go through it. So you have just pure sand and it would just get rid of any larger particles. So let's see what else it says. It says the diameter, so all the way across, is 35 feet and the slant length is 24 feet. Okay, it says calculate the height in feet inches. So the height is going to be straight down like that. And so you have a right angle right here. So that's what we're solving for, that red line. So if you notice, we're working with half the cone. So you can't use 35. That's where the biggest mistake is. So you're going to want to take that 35 and divide it by 2, and you got 17.5. Because really you want to work with the radius right here from here to here. So I'm going to redraw this so you can see a little bit better. So I'm working with the radius of 17.5 and 24 feet, and I'm going to solve for the height of the cone. So it says use Pythagorean theorem. So if you don't remember which one you're going to use in the Pythagorean theorem, you're going to go to your formula package, go to the trig section, and then you could see Pythagorean theorem, and you want this one because it says height. And remember, C is the slant length or the longest one. So that's the one that really matters. So instead of B squared, I'll use H squared for height. But you basically can write H squared equals, so C squared is the longest one, so 24 squared minus a 17.5 squared. And you could just type that in your calculator. So you're going to go 24 squared minus 17.5 squared and hit equals. So you're going to get 269.75. Now, remember that's h squared. We want to solve for just h. So you have to do the square root of 269.75. Because remember, your height should be smaller than the hypotenuse, which is 24. So square root of that answer, and you get 16.4241. And so you're not done because that's just pure feet. And I want the answer in feet inches. So remember, you're going to use the staircase method. If you don't remember how to do the staircase method, go back to your video in trig labeled staircase method. All right, let's look at number 15. So 15 says calculate for the volume of the cone. So volume of the cone, so then we have to go to our formula package to see what the formula is. So make sure you go to measurement, and we're working with 3D shapes now because we're doing a cone. So scroll down to 3D shapes. There's cone, and volume is pi r squared times the height divided by 3. So I'm going to write that down. So I've got volume equals pi r squared multiplied with the height divided by 3. So you're just going to plug in the numbers. So remember the radius was 17.5, so be careful. Not using the diameter, so squared times the height, which I got 16.4241. And then I'm going to divide that all by 3. And so you could just plug that all into your calculator. So I'm going to go pi times 17.5 squared times 16.4241 equals, and then I'm going to hit divided by 3. So I've got 5,267.2787, and that's feet cubed. Okay, so now I'm going to look at number 16. 16 says calculate the weight. It's 95 pounds for feet cubed. So what I'm going to do is first set up your ratio. So I've got for 16, I've got it's 95 pounds for 1 feet cubed. So I don't know the pounds. So that's going up in the numerator over, and I have feet cubed. That's what I solved for in the previous question. So it's 5,267.2. I'm just going to write 8 just because I ran out of space there. But I kept it all in my calculator. So I'm going to cross multiply. So I'm going to take that answer, multiply it with 95, hit equals, and I've got my answer. So I've got 500,391. That's all I'm going to write because that's all I'm working with. And so that's my pounds.